Question 1. Assessment of the most effective strategy for optimizing alert processing performance in an IBM Tivoli Netcool/OMNIbus V7 for environment, considering potential impacts on system stability and resource utilization. Option A. Immediately deploy all newly developed correlation rules to maximize alert correlation capabilities across the entire system. Option B. Disable all advanced correlation features to reduce the processing load on the object server. Option C. Implement a phased rollout of newly developed, more complex correlation rules, accompanied by rigorous performance monitoring and resource utilization analysis at each stage. Option D. Focus solely on upgrading server hardware and increasing network bandwidth to accommodate the current alert volume. Correct answer is C. Implement a phased rollout of newly developed, more complex correlation rules, accompanied by rigorous performance monitoring and resource utilization analysis at each stage. Explanation. This scenario presents a professional challenge in optimizing the performance of an IBM Tivoli Netcool/OMNIbus V7 for environment, specifically concerning the efficient processing of alerts. The core difficulty lies in balancing the need for rapid alert ingestion and correlation with the potential for resource contention and performance degradation. Careful judgment is required to select an approach that enhances efficiency without negatively impacting system stability or data integrity. The correct approach represents best professional practice because it directly addresses the underlying causes of alert processing bottlenecks. By implementing a phased rollout of enhanced correlation rules and carefully monitoring resource utilization, it ensures that changes are validated and their impact is understood before full deployment. This aligns with the principles of robust system management and change control, minimizing risk and ensuring continuous service availability. While specific regulations for Netcool/OMNIbus are not explicitly defined in a broad sense, industry best practices and the implicit requirement for reliable IT service delivery, as often mandated by service-level agreements, SLAs, and internal governance frameworks, necessitate such a methodical and risk-averse approach. An incorrect approach that involves immediately deploying a large number of complex correlation rules without prior testing or phased implementation represents a significant regulatory and ethical failure. From a regulatory perspective, this could lead to a breach of SLAs due to system instability or data loss, incurring financial penalties and reputational damage. Ethically, it demonstrates a disregard for due diligence and a failure to uphold professional responsibility to deliver a stable and reliable service. Similarly, an approach that focuses solely on increasing hardware resources without analyzing the alert processing logic is inefficient and potentially wasteful, failing to address the root cause of performance issues and thus not representing best professional practice. It also fails to demonstrate responsible resource management, which is an implicit ethical consideration in IT operations. Professionals should employ a decision-making framework that prioritizes understanding the current state, identifying root causes, and implementing changes in a controlled and iterative manner. This involves thorough analysis, risk assessment, phased implementation, and continuous monitoring. The goal is to achieve optimal performance while maintaining system integrity and meeting service objectives. Question 2. Comparative studies suggest that optimizing the performance of an IBM Tivoli Netcool/OMNIbus V7 for environment requires a strategic approach, considering the critical nature of event management and the need to maintain service availability. Which of the following methodologies best balances efficiency gains with operational risk mitigation? Option A. Conducting a comprehensive analysis of current performance metrics, developing a phased implementation plan with rigorous testing in a staging environment, and establishing a clear rollback procedure before deploying changes to production. Option B. Relying solely on vendor-provided default configurations and avoiding any manual adjustments to prevent unintended consequences, even if performance issues are reported. Option C. Prioritizing the reduction of system resource utilization by disabling non-essential monitoring probes and reducing alert aggregation thresholds, regardless of potential impact on event visibility. Option D. Implementing performance tuning parameters directly in the production environment during peak operational hours to immediately observe their impact. Correct answer is D. Implementing performance tuning parameters directly in the production environment during peak operational hours to immediately observe their impact. Explanation: this scenario presents a common challenge in IT operations. Optimizing a critical system like IBM Tivoli Netcool/OMNIbus V7.4 for performance and reliability. The challenge lies in balancing the need for immediate improvements with the potential risks of disrupting ongoing operations or introducing new vulnerabilities. Careful judgment is required to select an optimization strategy that is both effective and compliant with established operational procedures and any relevant internal or external service level agreements, SLAs. The correct approach, which involves a phased, controlled implementation with thorough testing and rollback capabilities, represents best professional practice because it aligns with principles of risk management and operational stability. This methodology ensures that any changes are validated in a non-production environment before being deployed to production, minimizing the risk of service degradation or outage. It also adheres to the implicit regulatory and ethical obligation to maintain service availability and data integrity, as expected by stakeholders and potentially mandated by SLAs. Incorrect approaches, such as implementing changes directly in the production environment without prior testing or failing to establish a clear rollback plan, represent significant regulatory and ethical failures. Implementing changes without testing can lead to unforeseen performance issues or system failures, directly violating SLAs and potentially causing financial or reputational damage to the organization. The absence of a rollback plan exacerbates these failures, as it leaves the system vulnerable to prolonged downtime and makes recovery more complex and costly. Ethically, this demonstrates a disregard for the impact on end users and business operations. Another incorrect approach, focusing solely on cost reduction without considering the impact on performance or security, can lead to a system that is cheaper but less effective, potentially failing to meet critical monitoring and alerting requirements, which is a breach of professional duty. Professionals should employ a decision-making framework that prioritizes a systematic and risk-averse approach. This involves 1. Thoroughly understanding the current system performance and identifying specific bottlenecks or areas for improvement. 2. Researching and evaluating various optimization techniques, considering their potential impact, complexity, and required resources. 3. Developing a detailed implementation plan that includes testing in a staging environment, clear success criteria, and a robust rollback strategy. 4. Gaining stakeholder approval for the plan, especially if it involves any potential for service disruption. 5. Executing the plan in a controlled manner, monitoring performance closely during and after implementation. 6. Documenting all changes and outcomes for future reference and auditing. Question 3. The audit findings indicate that the event processing queue in IBM Tivoli Netcool/OMNIbus V7.4 is experiencing significant delays, leading to a backlog of alerts. Which of the following actions is the most appropriate first step to address this performance degradation? Option A. Immediately increase the buffer sizes for all object servers to accommodate the growing event backlog. Option B. Analyze object server performance metrics and probe logs to identify specific points of congestion within the event processing pipeline. Option C. Disable non-critical correlation rules to reduce the processing load on the object servers. Option D. Initiate a hardware upgrade for the servers hosting the object servers and probes. The correct answer is B. Analyze object server performance metrics and probe logs to identify specific points of congestion within the event processing pipeline. Explanation: the audit findings indicate a potential bottleneck in the event processing workflow within IBM Tivoli Netcool/OMNIbus V7.4. This scenario is professionally challenging because inefficient event processing can lead to delayed incident response, increased mean time to detect (MTTD) and mean time to resolve (MTTR), and ultimately impact service availability and customer satisfaction. The core of the challenge lies in identifying the root cause of the delay and implementing a solution that is both effective and compliant with operational best practices and any relevant internal service level agreements, SLAs, or industry standards that might be implicitly referenced by the exam scope. The correct approach involves a systematic and data-driven analysis of the event processing pipeline. This includes examining the performance of object servers, probes, and any associated automation or correlation rules. By leveraging the diagnostic tools and reporting capabilities within Netcool/OMNIbus, administrators can pinpoint specific stages where events are accumulating or being processed slowly. Optimizing these areas, perhaps by tuning probe configurations, adjusting object server buffer sizes, or refining SQL queries for event processing, represents best professional practice. This methodical approach ensures that changes are targeted, measurable, and contribute to overall system stability and performance, aligning with the principles of IT service management (ITSM) and operational excellence. An incorrect approach would be to make broad, unverified changes to the system configuration. For instance, indiscriminately increasing buffer sizes without understanding the underlying cause of the backlog could lead to increased memory consumption and potential system instability, rather than resolving the performance issue. This lacks the analytical rigor expected in a professional environment and could inadvertently introduce new problems. Another incorrect approach would be to disable critical event processing features or rules without a thorough understanding of their impact. This could lead to missed alerts, incomplete incident data, and a failure to meet operational objectives, potentially violating internal policies or SLAs. A third incorrect approach might be to focus solely on hardware upgrades without investigating software or configuration inefficiencies. While hardware can be a factor, it's often not the primary cause of processing delays in a well-tuned system, and such an approach would be a misallocation of resources and a failure to address the actual problem. Professionals should approach such situations by first gathering all available diagnostic data. This includes logs, performance metrics, and event flow analysis. Next, they should form hypotheses about the potential causes of the processing delay. Each hypothesis should then be tested through controlled experiments or further data analysis. Once the root cause is identified, a solution should be designed, implemented, and rigorously tested in a non-production environment before being deployed to production. Continuous monitoring after implementation is crucial to ensure the effectiveness of the solution and to detect any unforeseen side effects. This iterative, data-driven, and risk-aware process is fundamental to effective IT operations management. Question 4. To address the challenge of implementing a critical OMNIbus v7, configuration update that will enhance alert correlation capabilities, but requires a brief period of reduced monitoring visibility during the transition, what is the most professional and effective approach to gain stakeholder buy-in and ensure successful adoption? Option A. Inform the IT security team of the impending change and request their approval, but defer communication with business unit managers until after the update is successfully deployed to avoid unnecessary concern. Option B. Proceed with the OMNIbus configuration update without explicit stakeholder consultation, assuming that the technical benefits will be self-evident and that operational teams are accustomed to minor monitoring disruptions. Option C. Immediately implement the OMNIbus configuration update during a scheduled maintenance window, relying on existing operational procedures to manage any unforeseen issues, and inform stakeholders of the change retrospectively through a general IT update email. Option D. Conduct a comprehensive briefing session with all affected business unit managers and the IT security team, presenting a clear business case for the update, detailing the expected benefits, outlining the temporary reduction in visibility with mitigation strategies, and soliciting their feedback and approval before proceeding with the change. The correct answer is D. Conduct a comprehensive briefing session with all affected business unit managers and the IT security team, presenting a clear business case for the update, detailing the expected benefits, outlining the temporary reduction in visibility with mitigation strategies, and soliciting their feedback and approval before proceeding with the change. Explanation. This scenario presents a common challenge in IT service management, balancing the immediate need for operational stability with the long-term strategic goals of an organization. The stakeholder perspective is crucial here, as different groups will have varying priorities and understandings of the impact of OMNIbus configuration changes. The professional challenge lies in effectively communicating the value and risks associated with a proposed change to a critical monitoring system like Netcool/OMNIbus v7. 4. To diverse stakeholders, ensuring alignment and informed decision-making. The correct approach involves a structured communication strategy that clearly articulates the technical rationale, business benefits, and potential risks of the proposed OMNIbus configuration change. This includes demonstrating how the change aligns with broader IT governance principles and operational efficiency objectives. By providing clear, concise, and relevant information tailored to each stakeholder group, the IT team can foster understanding, gain buy-in, and mitigate potential resistance. This proactive engagement ensures that decisions are made with a comprehensive understanding of the implications, adhering to best practices in IT service management and change control. An incorrect approach would be to proceed with the configuration change without adequate stakeholder consultation. This could lead to misunderstandings, unexpected operational disruptions, and a lack of support for future initiatives. Specifically, failing to involve the business unit managers who rely on the monitoring data for their daily operations represents a significant ethical and professional failure. It demonstrates a disregard for the impact on business continuity and could lead to reputational damage for the IT department. Similarly, bypassing the security team's review process for changes to a system that handles sensitive operational data is a critical regulatory and security oversight. This could expose the organization to vulnerabilities and non-compliance with data protection policies. Not providing a clear business case to senior management risks the perception that the change is merely a technical exercise rather than a strategic improvement, potentially jeopardizing resource allocation and future project approvals. The professional decision-making process should involve a thorough impact assessment, followed by targeted communication plans for each stakeholder group. This includes identifying key stakeholders, understanding their interests and concerns, and developing clear messaging that addresses these points. A robust change management process, which includes risk assessment, testing, and rollback plans, should be integral to the decision-making framework. Prioritizing transparency and collaboration ensures that all parties are informed and have an opportunity to contribute, leading to more effective and sustainable IT solutions. Question 5. Benchmark analysis indicates that an alert storm in IBM Tivoli Netcool /OMNIbus v7.4 is severely impacting service availability. A proposed immediate workaround involves clearing alert data directly from the database to reduce the load. From a stakeholder perspective, what is the most professional and compliant approach to address this situation? Option A. Inform stakeholders that the alert storm is a known issue and await a permanent fix from the vendor without implementing any immediate workaround. Option B. Implement the workaround to clear alert data immediately, then perform a root cause analysis and data validation after service is restored. Option C. Prioritize data integrity by first archiving or backing up the alert data that will be cleared, then implement the workaround, followed by validation and root cause analysis. Option D. Apply the workaround to clear alert data, and if any data inconsistencies are discovered later, attempt to restore from the most recent available backup. The correct answer is B. Implement the workaround to clear alert data immediately, then perform a root cause analysis and data validation after service is restored. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in balancing the immediate operational needs of a critical IT service with the long-term strategic goals of data integrity and compliance. The Netcool /OMNIbus administrator is tasked with resolving an alert storm that is impacting service availability. However, the proposed solution, while expedient, carries a significant risk of data loss or corruption if not implemented with extreme care. The challenge lies in making a decision that mitigates the immediate crisis without compromising the fundamental principles of data management and the regulatory expectations for system stability and auditability. Careful judgment is required to assess the severity of the alert storm against the potential consequences of the proposed workaround. Correct approach analysis. The correct approach involves a phased implementation that prioritizes data integrity and auditability. This means first ensuring that any data that could be lost or corrupted during the workaround is backed up or archived. Subsequently, the workaround is applied, followed by a thorough validation process to confirm that the alert storm is resolved and that no unintended data issues have arisen. Finally, a root cause analysis is performed to prevent recurrence. This approach aligns with best professional practices by adhering to the principles of data governance, risk management, and continuous improvement. From a regulatory perspective, This methodical approach demonstrates due diligence in protecting critical system data and ensuring system stability, which are often implicit or explicit requirements in IT service management frameworks, and potentially in industry-specific regulations concerning data retention and system availability. Incorrect approach is analysis. Implementing the workaround without any form of data backup or archiving is professionally unacceptable. This approach directly violates the principle of data integrity and introduces a high risk of irreversible data loss or corruption. From a regulatory standpoint, this could be seen as negligence, especially if the lost data is critical for auditing, reporting, or business continuity. It fails to meet the expected standards of care in managing IT systems. Applying the workaround and then attempting to restore data from a potentially incomplete or inconsistent backup after the fact is also professionally unsound. This reactive approach increases the likelihood of data inconsistencies and further system downtime. It demonstrates a lack of foresight and proactive risk management, which is a failure in professional responsibility. Regulatory bodies would likely view this as a failure to implement adequate controls for data protection and system resilience. Ignoring the alert storm and waiting for it to resolve on its own is a dereliction of duty. While it avoids immediate risk to data integrity from the workaround, it fails to address the critical issue of service availability. This can lead to significant business disruption and reputational damage. Professionally, this is unacceptable as it neglects the core responsibility of maintaining system performance and availability. It also implicitly violates any service-level agreements, SLAs, and could have regulatory implications if the service disruption impacts regulated activities. Professional reasoning. Professionals in this situation should employ a structured decision-making process that begins with a thorough assessment of the immediate impact of the alert storm on service availability and business operations. This should be followed by an evaluation of the risks associated with the proposed workaround, specifically focusing on potential data loss or corruption. The decision should then be guided by established IT service management best practices, such as those outlined in ITIL, which emphasize incident management, problem management, and change management. A key element of this process is risk mitigation, which dictates that any action taken to resolve an incident must consider its potential downstream effects. Prioritizing data integrity and system stability, even when under pressure, is paramount. If a workaround is necessary, it must be implemented with appropriate safeguards, including backups and validation. The ultimate goal is to resolve the immediate issue while ensuring long-term system health and compliance with any applicable regulations. Question 6. Cost-benefit analysis shows that a new low-cost monitoring tool from a third-party vendor offers significant potential for reducing operational overhead in managing alerts within IBM Tivoli Netcool /OMNIbus v7. 4. However, the vendor's documentation is vague regarding data handling practices and compliance certifications. A senior operations manager is eager to implement this tool quickly to realize immediate cost savings. What is the most prudent approach to evaluating and potentially adopting this new monitoring tool? Option A. Rely on the vendor's assurances of compliance and security, and implement the tool after a brief discussion with the senior operations manager to confirm their understanding of the benefits. Option B. Implement the tool in a limited, non-production environment to test its functionality without conducting a formal security or compliance review, assuming that any issues will be minor and easily resolved. Option C. Conduct a comprehensive security and compliance review of the vendor and the tool, including a thorough assessment of how it handles alert data and integrates with existing Netcool /OMNIbus v7. 4. Security policies before any implementation. Option D. Proceed with the immediate implementation of the tool to capture the projected cost savings and address any potential security or compliance issues that arise post-deployment. The correct answer is C. Conduct a comprehensive security and compliance review of the vendor and the tool, including a thorough assessment of how it handles alert data and integrates with existing Netcool /OMNIbus v7. 4. Security policies before any implementation. Explanation. This scenario presents a professional challenge because it requires balancing the immediate perceived benefits of a new technology with the potential long-term risks and compliance obligations. The stakeholder perspective is crucial here, as different groups will have varying priorities and understanding of the implications. The core of the challenge lies in ensuring that the adoption of a new tool, even one that appears cost-effective on the surface, does not inadvertently lead to regulatory noncompliance or introduce unacceptable security vulnerabilities. Careful judgment is needed to move beyond superficial cost savings and consider the broader impact on data integrity, privacy, and operational resilience. The correct approach represents best professional practice because it prioritizes a thorough, risk-based assessment that aligns with established IT governance principles, and by extension, the spirit of regulatory frameworks governing data handling and system integrity. It acknowledges that cost-benefit is not solely a financial metric, but encompasses risk mitigation, compliance assurance, and operational stability. This approach ensures that any technology adoption is evaluated against its potential impact on sensitive data, adherence to data protection regulations. Even if not explicitly stated in the exam syllabus, the principles are universal in IT governance, and the overall security posture of the organization. It demonstrates due diligence and a commitment to responsible technology deployment. Each incorrect approach carries specific regulatory and ethical failures. Implementing a solution based solely on a vendor's claims without independent validation or a comprehensive risk assessment ignores the fundamental principle of accountability in data management. This can lead to breaches of data privacy regulations if the solution mishandles sensitive information, or to operational failures that violate service-level agreements and potentially regulatory requirements for system availability. Furthermore, bypassing established change management and security review processes is an ethical lapse, as it undermines organizational controls designed to protect both the organization and its customers. Relying on a single stakeholder's opinion without broader consultation is also problematic, as it can lead to decisions that benefit one group at the expense of others or the organization as a whole, potentially creating blind spots regarding compliance and security. Professionals should employ a decision-making framework that begins with clearly defining the problem and objectives. This is followed by identifying all relevant stakeholders and their perspectives. A comprehensive assessment of potential solutions should then be conducted, encompassing not only cost and functionality, but also security, compliance, scalability, and integration. A formal risk assessment and mitigation plan should be integral to this evaluation. Finally, decisions should be documented, justified, and communicated to relevant parties, with a clear understanding of the implications for ongoing monitoring and management. This structured approach ensures that decisions are informed, defensible, and aligned with organizational goals and regulatory expectations. Question 7. Benchmark analysis indicates that the IT operations team is facing increasing pressure to resolve critical alert storms impacting service availability, while the business development team is advocating for the implementation of new Netcool/OMNIbus v7. 4 features to support upcoming product launches. Considering the stakeholder perspectives and the need for a balanced approach to resource allocation, which strategy best aligns with the principles of effective IT service management and operational resilience within the C2010-593 exam scope? Option A. Prioritize the implementation of new Netcool/OMNIbus v7. 4 features to meet the business development team's deadlines, deferring the resolution of alert storms until after the new features are deployed. Option B. Establish a cross-functional working group to assess the business impact of both the alert storms and the proposed enhancements, and collaboratively develop a prioritized roadmap that balances immediate operational needs with strategic objectives. Option C. Delegate the decision-making authority to the IT operations manager, who is best positioned to understand the technical urgency of the alert storms. Option D. Immediately halt all enhancement work and dedicate all available resources to resolving the alert storms to restore immediate service stability. The correct answer is D. Immediately halt all enhancement work and dedicate all available resources to resolving the alert storms to restore immediate service stability. Explanation: this scenario presents a professional challenge because it requires balancing the immediate need for operational stability with the long-term strategic goals of IT service management, specifically within the context of IBM Tivoli Netcool/OMNIbus v7. 4. The core of the challenge lies in understanding how different stakeholder perspectives influence the prioritization of system enhancements versus immediate issue resolution. The regulatory framework for this exam C2010-593 IBM Tivoli Netcool /OMNIbus V7. 4 Fundamentals implicitly emphasizes the importance of robust and reliable event management systems, which directly impacts business continuity and service delivery. The correct approach represents best professional practice because it acknowledges the diverse needs and priorities of different business units. By engaging in a structured dialogue that quantifies the impact of both immediate issues and proposed enhancements, IT management can make informed decisions aligned with overall business objectives. This aligns with the principles of IT service management, ITSM, frameworks, which advocate for a holistic view of service delivery and stakeholder engagement. The focus on understanding the business impact of both reactive issue resolution and proactive enhancement activities ensures that resources are allocated effectively to maximize value and minimize risk, a key tenet in maintaining operational integrity as expected by IT governance. Incorrect approaches fail to adequately consider the broader implications of their decisions. Prioritizing only immediate issue resolution without considering strategic enhancements can lead to technical debt and missed opportunities for improved efficiency and resilience, potentially violating implicit regulatory expectations for maintaining a secure and performant system. Conversely, solely focusing on enhancements without addressing critical operational issues can lead to service degradation and business disruption, which is a direct contravention of the fundamental requirement for a stable event management system. Failing to involve key stakeholders in the decision-making process or making decisions based on incomplete information demonstrates a lack of due diligence and can lead to misaligned priorities and wasted resources, ultimately impacting the organization's ability to meet its operational and compliance obligations. The professional reasoning process for similar situations should involve a multifaceted approach. First, clearly identify all relevant stakeholders and understand their primary concerns and objectives. Second, gather data to quantify the impact of both immediate issues and proposed enhancements, focusing on business metrics such as downtime, revenue loss, customer satisfaction, and operational efficiency. Third, facilitate open communication and collaboration among stakeholders to build consensus on priorities. Finally, document the decision-making process and the rationale behind the chosen course of action, ensuring transparency and accountability. This structured approach ensures that decisions are not only technically sound, but also strategically aligned with business goals and regulatory expectations. Question 8. Consider a scenario where a critical IBM Tivoli Netcool /OMNIbus probe is failing to process incoming events due to an unexpected data format change from a monitored source, causing a significant increase in unacknowledged alerts and impacting service monitoring. The operations team is under immense pressure from business stakeholders to restore alert processing immediately. What is the most professionally responsible course of action? Option A. Implement a temporary, undocumented script to filter out the malformed events, allowing the probe to resume processing other events, and schedule a proper fix for the probe configuration for the next maintenance window. Option B. Immediately restart the probe and the associated object server without any further investigation or documentation, hoping the issue resolves itself. Option C. Inform stakeholders that the issue is complex and will require significant downtime to resolve, without offering any immediate mitigation. Option D. Develop and deploy a robust, documented workaround that filters the malformed events and ensures proper logging of the event processing status, while simultaneously initiating the process to permanently correct the probe's configuration. The correct answer is A. Implement a temporary, undocumented script to filter out the malformed events, allowing the probe to resume processing other events, and schedule a proper fix for the probe configuration for the next maintenance window. Explanation. This scenario presents a professional challenge due to the inherent tension between operational efficiency and data integrity within a critical IT infrastructure component like IBM Tivoli Netcool /OMNIbus. The need to quickly resolve an outage, a primary stakeholder concern, must be balanced against the long-term implications of data accuracy and auditability, which are also crucial for other stakeholders such as compliance and security teams. The challenge lies in making a decision that appeases immediate operational demands without compromising the system's reliability and trustworthiness for future analysis and regulatory adherence. The correct approach, which involves meticulously documenting the workaround and planning for a proper fix, represents best professional practice because it acknowledges the immediate need while adhering to principles of good system management and data governance. This aligns with the implicit regulatory expectation of maintaining accurate and auditable system records, even during emergency situations. By documenting the workaround, the team ensures that the system state and the actions taken are recorded, providing a basis for future troubleshooting and compliance reporting. Planning for proper fix demonstrates a commitment to restoring the system to a stable and supported state, preventing recurrence and maintaining data integrity. An incorrect approach that bypasses documentation and immediate remediation planning for the workaround would represent a significant regulatory and ethical failure. This failure stems from a disregard for data integrity and auditability. If the workaround is not documented, it becomes impossible to trace the system's behavior during the outage, hindering root cause analysis and potentially masking underlying issues. This lack of transparency can lead to noncompliance with regulations that mandate accurate record-keeping of system operations and changes. Furthermore, failing to plan for a proper fix creates technical debt and increases the risk of future, potentially more severe, incidents which could be viewed as professional negligence. Another incorrect approach, which prioritizes immediate, undocumented, and potentially unstable fixes over a structured workaround, also fails professionally. This approach prioritizes speed over stability and correctness, risking further system degradation or data corruption. Such actions undermine the trust stakeholders place in the IT operations team and can lead to significant compliance issues if the system's integrity is compromised, as regulatory frameworks often require systems to operate in a predictable and auditable manner. The professional reasoning process for similar situations should involve a rapid assessment of the impact of the outage, identification of immediate mitigation strategies, workarounds, and a clear understanding of the trade-offs involved. Stakeholder communication is paramount to manage expectations. Crucially, any deviation from standard operating procedures, especially during an incident, must be meticulously documented. A post-incident review should then be conducted to implement permanent solutions and refine incident response procedures, ensuring that operational needs are met without sacrificing data integrity or regulatory compliance. Question 9. The investigation demonstrates that IBM Tivoli Netcool /OMNIbus v7.4 is experiencing intermittent performance degradation, affecting the timely alerting of critical network events to multiple stakeholder groups. The IT operations team is under pressure to restore full functionality rapidly. Which of the following approaches represents the most professional and effective method for addressing this issue? Option A. Proactively disable non-essential alert processing rules to reduce the load on the OMNIbus server, hoping to alleviate the performance problem. Option B. Immediately restart all OMNIbus services and associated database instances to clear any potential temporary glitches. Option C. Systematically collect and analyze OMNIbus performance metrics, system logs, and recent configuration changes to identify the root cause before implementing any remediation steps. Option D. Initiate a rollback of the most recent OMNIbus configuration changes, assuming they are the cause of the performance issue. The correct answer is B. Immediately restart all OMNIbus services and associated database instances to clear any potential temporary glitches. Explanation. This scenario presents a common challenge in IT operations where a critical system, IBM Tivoli Netcool /OMNIbus v7.4, experiences performance degradation impacting multiple business units. The professional challenge lies in diagnosing the root cause of the performance issue while minimizing disruption to ongoing business operations and adhering to established operational procedures and potential service level agreements, SLAs, that might be implicitly or explicitly in place. The need for a structured, evidence-based approach is paramount to avoid misdiagnosis, unnecessary system changes, and potential escalation of the issue. The correct approach involves a systematic investigation that prioritizes data collection and analysis before implementing any changes. This aligns with best professional practices for incident management and problem resolution. By first gathering detailed performance metrics, system logs, and configuration data, the IT team can form a hypothesis about the cause of the degradation. This data-driven methodology ensures that any subsequent actions are targeted and informed, reducing the risk of introducing new problems or exacerbating the existing one. This approach is implicitly supported by general IT best practices and the principles of effective system administration, which emphasize understanding before acting. While specific regulations for OMNIbus performance are not typically mandated by external bodies in the same way financial regulations are, adherence to internal IT governance frameworks and operational procedures, which are designed to ensure service availability and integrity, is a professional imperative. An incorrect approach would be to immediately restart services or make configuration changes without understanding the underlying cause. Restarting services might offer a temporary fix but fails to address the root cause, leading to recurring issues and potentially violating SLAs if the problem persists. Making configuration changes without data analysis is highly risky. It could worsen the performance, cause system instability, or lead to data loss. This demonstrates a failure in professional judgment and adherence to sound IT operational principles. It also risks violating internal policies that mandate a structured incident response process, which often requires documented investigation steps and root cause analysis before remediation. The professional decision-making process for similar situations should involve 1. Incident identification and prioritization. Clearly define the problem and its impact. 2. Information gathering. Collect all relevant data, logs, metrics, configuration, user reports. 3. Analysis and hypothesis formation. Analyze the collected data to identify potential causes. 4. Testing and validation. Formulate and test hypotheses in a controlled manner if possible. 5. Remediation. Implement the solution based on validated findings. 6. Verification. Confirm the issue is resolved and monitor for recurrence. 7. Documentation and postmortem. Document the incident, resolution, and lessons learned. Question 10. Upon reviewing the current operational status of the IT infrastructure, a key business executive has requested a concise summary of any critical issues impacting service delivery, focusing on the business implications rather than granular technical details. Considering the capabilities of IBM Tivoli Netcool /OMNIbus v7. 4. Which approach would best satisfy this request while adhering to professional IT service management practices? Option A. Configure OMNIbus to correlate and aggregate related events, presenting management with a summarized view of service disruptions and their identified root causes, along with estimated business impact. Option B. Forward all raw, unfiltered alerts generated by OMNIbus directly to the executive's inbox for their review. Option C. Manually compile a daily report by sifting through individual OMNIbus alerts and summarizing them based on personal judgment. Option D. Provide the executive with a detailed technical log of all active alerts, emphasizing the specific error codes and system components involved. The correct answer is A. Configure OMNIbus to correlate and aggregate related events, presenting management with a summarized view of service disruptions and their identified root causes, along with estimated business impact. Explanation. This scenario presents a professional challenge rooted in the effective management of IT infrastructure and the communication of its status to diverse stakeholders. The core difficulty lies in translating technical operational details into information that is meaningful and actionable for non-technical business leaders, while also ensuring compliance with internal governance and potentially external reporting requirements. Though for this exam, we focus on internal best practices and the OMNIbus framework. The need to balance detailed technical accuracy with high-level business impact is paramount. The correct approach, focusing on leveraging OMNIbus's event correlation and aggregation capabilities to provide a summarized, impact-oriented view, represents best professional practice. This aligns with the fundamental purpose of an IT service management (ITSM) tool like OMNIbus, to provide visibility and control over IT operations. By correlating related events, the system can identify the root cause of an issue and its broader impact on services, rather than presenting a deluge of raw alerts. This allows for more efficient decision-making by management, enabling them to prioritize resources and understand business risk. This approach implicitly supports internal governance by providing a clear, auditable trail of incidents and their resolution, and by ensuring that communication is focused on business outcomes, which is a key tenet of effective IT governance. An incorrect approach would be to simply forward all raw alerts from OMNIbus to management. This fails to add value and overwhelms non-technical stakeholders with data they cannot effectively interpret. It represents a failure to understand the audience and the purpose of reporting, potentially leading to misinformed decisions or a lack of confidence in the IT department. Ethically, it's a failure to communicate effectively and responsibly. Another incorrect approach would be to manually filter and summarize alerts without leveraging OMNIbus's built-in intelligence. While seemingly addressing the need for summarization, this is inefficient, prone to human error, and bypasses the powerful correlation and aggregation features designed to automate this process. This approach is professionally suboptimal as it relies on manual effort where automation is available, increasing the risk of missed critical events or inaccurate summaries. It also fails to demonstrate an understanding of how to best utilize the deployed OMNIbus solution. A third incorrect approach would be to focus solely on the technical resolution of individual alerts without considering their cumulative impact on business services. This demonstrates a lack of strategic thinking and a failure to connect IT operations to business objectives. While individual alerts might be resolved, the underlying service degradation or outage could persist, leading to significant business disruption that management is unaware of. This is a failure in proactive service management and stakeholder communication. Professional reasoning process should involve understanding the audience's needs and information requirements. For management, this typically means understanding the impact on business services, potential financial implications, and the timeline for resolution. The professional should then consider the capabilities of the deployed tools, such as OMNIbus, to meet these needs. Leveraging features like event correlation, aggregation, and service impact modeling is crucial. The decision-making process should prioritize solutions that provide actionable insights and support informed business decisions, rather than simply presenting raw data. This involves a continuous feedback loop with stakeholders to ensure the information provided is relevant and valuable. Question 11. The control framework reveals that an urgent security vulnerability has been identified in IBM Tivoli Netcool /OMNIbus v7. 4. Requiring immediate patching. The administrator must decide on the best course of action to address this vulnerability while minimizing potential disruption to critical monitoring services. Which of the following approaches best aligns with professional IT service management and security best practices? Option A. Apply the patch without prior testing or rollback planning, assuming it will resolve the issue without complications. Option B. Immediately apply the patch during business hours to ensure the vulnerability is addressed as quickly as possible. Option C. Defer patching until a less critical period, accepting the risk of the vulnerability for the sake of uninterrupted service. Option D. Schedule the patch deployment during a planned maintenance window after thorough testing, communication with stakeholders, and confirmation of a viable rollback strategy. Correct answer is B. Immediately apply the patch during business hours to ensure the vulnerability is addressed as quickly as possible. Explanation. The control framework reveals a situation where an administrator is tasked with implementing a critical security patch for IBM Tivoli Netcool /OMNIbus v7. 4. The challenge lies in balancing the urgency of patching a known vulnerability against the potential for service disruption. The administrator must consider the impact on business operations, the availability of rollback procedures, and the established change management protocols. This scenario is professionally challenging because a hasty decision could lead to system downtime, affecting critical monitoring services, while delaying the patch could expose the system to security risks. The correct approach involves a thorough risk assessment and adherence to the established change management process. This includes verifying the patch's compatibility, planning for a maintenance window, communicating the planned downtime to stakeholders, and having a robust rollback plan in place. This represents best professional practice because it aligns with the principles of IT service management (ITSM) and operational security, ensuring that changes are implemented in a controlled and predictable manner, minimizing risk to the business. Adhering to these procedures is implicitly mandated by the need for reliable and secure IT operations, which are foundational to maintaining business continuity and data integrity, as expected by organizational policies and industry best practices, even if not explicitly tied to a specific UK/CISI regulation in this context. An incorrect approach would be to immediately apply the patch without proper planning or testing. This fails to account for potential unforeseen issues, such as conflicts with existing configurations or dependencies, which could lead to system instability or complete failure. This bypasses critical risk mitigation steps and demonstrates a disregard for the impact on service availability, violating the professional responsibility to maintain stable and reliable systems. Another incorrect approach would be to delay the patch indefinitely due to fear of disruption, without any attempt to mitigate the risks associated with the vulnerability. This exposes the organization to potential security breaches, data loss, or service compromise, which is a failure to uphold the duty of care expected of an IT professional responsible for system security. A third incorrect approach would be to apply the patch during peak operational hours without prior notification. This demonstrates a lack of consideration for business operations and stakeholder impact, leading to unnecessary disruption and loss of productivity. It signifies a failure to communicate effectively and manage change responsibly. Professionals should employ a structured decision-making framework that prioritizes risk assessment, impact analysis, and adherence to established procedures. This involves understanding the business context, evaluating the severity of the issue, considering available resources and expertise, and following a documented change management process. The goal is to make informed decisions that balance security imperatives with operational stability and business continuity. Question 12. Examination of the data shows a recurring, low-severity alert in IBM Tivoli Netcool /OMNIbus v7. 4 related to a specific network device, which has not caused any reported service degradation. The alert appears intermittently, approximately once every 48 hours, and the associated event details are not immediately indicative of a critical failure. What is the most professionally responsible course of action to address this situation? Option A. Escalate the alert directly to the vendor support team for their analysis and resolution, as it is a recurring issue. Option B. Document the alert and decide to take no immediate action, as it has not caused any service impact and occurs infrequently. Option C. Initiate a detailed investigation using Netcool /OMNIbus diagnostic tools and historical event data to identify the root cause of the recurring alert, while continuing to monitor for any escalation in severity or frequency. Option D. Immediately restart the affected network device to clear the alert and prevent any potential future issues, as a precautionary measure. The correct answer is C. Initiate a detailed investigation using Netcool /OMNIbus diagnostic tools and historical event data to identify the root cause of the recurring alert, while continuing to monitor for any escalation in severity or frequency. Explanation. This scenario presents a common challenge in IT operations, balancing immediate system stability with the need for comprehensive data analysis and proactive problem resolution. The professional challenge lies in determining the most effective and compliant course of action when faced with an anomaly that could indicate a critical issue, but without definitive proof. The urgency of potential service disruption must be weighed against the risk of unnecessary intervention and the potential for data loss or corruption if actions are taken without proper understanding. The correct approach represents best professional practice because it prioritizes a systematic, data-driven investigation before implementing potentially disruptive changes. This aligns with the principles of responsible IT management, which emphasize understanding the root cause of issues before applying solutions. By leveraging the diagnostic tools and historical data available within IBM Tivoli Netcool /OMNIbus v7. 4. The administrator can gather evidence, identify patterns, and make an informed decision. This methodical process minimizes the risk of unintended consequences and ensures that any subsequent actions are targeted and effective, thereby maintaining service integrity and adhering to operational best practices. An incorrect approach that involves immediately restarting services without investigation is professionally unacceptable. This action bypasses the diagnostic capabilities of Netcool /OMNIbus and ignores the opportunity to understand the underlying cause. Ethically, this could lead to recurring issues if the root cause is not addressed, potentially impacting service-level agreements and customer trust. From a regulatory perspective, depending on the nature of the services managed, Such a reactive and uninformed approach could be seen as a failure to exercise due diligence in maintaining system stability and security. Another incorrect approach, such as ignoring the anomaly due to its infrequent occurrence, is also professionally unsound. While not immediately critical, such anomalies can be early indicators of developing problems. Failing to investigate them constitutes negligence and a breach of professional responsibility to maintain system health. This could lead to more significant outages later, resulting in greater disruption and potential noncompliance with operational standards or service-level agreements. A third incorrect approach, which is to immediately escalate the issue to a higher support tier without any initial analysis, is inefficient and potentially costly. While escalation is a valid step, doing so without performing basic troubleshooting wastes valuable resources and delays resolution. It demonstrates a lack of initiative and an abdication of the administrator's responsibility to perform initial diagnostics, which is a core expectation in IT operations. The professional reasoning framework to employ in such situations involves a structured decision-making process. 1. Observe and document. Note the anomaly, its timing, and any associated symptoms. 2. Gather information. Utilize Netcool/OMNIbus tools to collect relevant event data, historical trends, and system logs. 3. Analyze data. Look for patterns, correlations, and potential root causes based on the gathered information. 4. Formulate hypotheses. Develop potential explanations for the anomaly. 5. Test hypotheses, if possible. Perform controlled tests or simulations to validate hypotheses. 6. Determine action. Based on the analysis, decide on the most appropriate course of action, which may include further investigation, configuration changes, or escalation. 7. Implement and monitor. Execute the chosen action and closely monitor the system for the resolution of the anomaly and any new issues. Question 13. Performance analysis shows a consistent increase in event processing latency within the IBM Tivoli Netcool/OMNIbus v7.4 environment over the past 48 hours, impacting alert correlation and forwarding. This degradation is not yet at a critical threshold but is trending negatively. What is the most appropriate immediate course of action? Option A. Escalate the issue directly to IBM support for immediate vendor intervention. Option B. Initiate a detailed review of recent configuration changes and system logs to identify potential root causes before implementing any corrective actions. Option C. Immediately roll back the most recent configuration changes made to the OMNIbus server and related components. Option D. Continue passive monitoring of the performance metrics, assuming the issue may resolve itself. The correct answer is B. Initiate a detailed review of recent configuration changes and system logs to identify potential root causes before implementing any corrective actions. Explanation. This scenario presents a common challenge in IT operations, balancing immediate system stability with the need for long-term performance optimization. The professional challenge lies in interpreting performance data, understanding the potential impact of different actions on a critical system like Netcool/OMNIbus, and making a decision that aligns with operational best practices, and implicitly, the service-level agreements, SLAs, that govern system availability and responsiveness. The regulatory framework for this exam, C2010-593 IBM Tivoli Netcool/OMNIbus v7.4 fundamental, while not explicitly detailing external regulations, implies adherence to internal IT governance, operational procedures, and the principles of sound system management. The correct approach involves a systematic, data-driven investigation before implementing any changes. This aligns with best professional practice by prioritizing a thorough understanding of the root cause of the performance degradation. It ensures that any proposed solution is targeted, effective, and minimizes the risk of unintended consequences. This methodical approach is crucial for maintaining system integrity and meeting operational objectives, which are the underlying principles of effective IT service management. An incorrect approach of immediately rolling back recent configuration changes without verifying if those changes are the actual cause represents a failure in professional reasoning. It assumes a direct correlation between recent activity and current performance issues, which may not be accurate. This could lead to unnecessary downtime or disruption if the rollback fails to resolve the problem or introduces new ones. Ethically, it could be seen as a failure to exercise due diligence in diagnosing and resolving a critical issue. Another incorrect approach, that of continuing to monitor without any proactive investigation is also professionally unsound. While monitoring is essential, passive observation in the face of performance degradation is insufficient. It fails to meet the implicit obligation to actively manage and maintain system health. This can lead to prolonged periods of degraded service, impacting users and potentially violating SLAs. It demonstrates a lack of initiative and a reactive rather than proactive stance. A third incorrect approach, that of immediately escalating to a vendor without performing initial troubleshooting, bypasses the organization's internal expertise and established support processes. While vendor support is valuable, it should be leveraged after internal teams have gathered sufficient diagnostic information. This approach can lead to delays and increased costs, and it fails to demonstrate the organization's capacity for self-sufficiency in managing its IT infrastructure. It also represents a missed opportunity for internal skill development. The professional decision-making process in such situations should follow a structured problem-solving framework. 1. Define the problem clearly based on performance analysis. 2. Gather relevant data and context, e.g., recent changes, system logs, resource utilization. 3. Formulate hypotheses about potential causes. 4. Test hypotheses through targeted investigation and analysis. 5. Implement the most likely solution based on evidence. 6. Verify the resolution and monitor for recurrence. 7. Document the process and findings. Question 14. Quality control measures reveal that following a recent configuration change in IBM Tivoli Netcool / OMNIbus v7. 4. The system is experiencing intermittent alert flooding and performance degradation. The change involved modifying event correlation rules. The operations team is under pressure to restore normal service levels quickly. What is the most appropriate immediate course of action to address the situation while ensuring system stability and data integrity? Option A. Revert to the most recent full system backup to ensure a clean and stable environment, even if it means losing some recent event data. Option B. Continue monitoring the system closely and document the alert patterns, assuming the issue will self-resolve or is a temporary anomaly. Option C. Apply the latest available hotfix for IBM Tivoli Netcool / OMNIbus v7. 4. To address potential software bugs that might be causing the alert flooding. Option D. Immediately roll back the recent configuration, change to the previous stable state, and simultaneously engage IBM Tivoli Netcool / OMNIbus support for root cause analysis of the new rules. The correct answer is D. Immediately roll back the recent configuration, change to the previous stable state, and simultaneously engage IBM Tivoli Netcool / OMNIbus support for root cause analysis of the new rules. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for system stability with the long-term implications of data integrity and compliance. The core of the challenge lies in making a decision under pressure, where a hasty choice could lead to significant operational disruption or regulatory scrutiny. The professional must consider the potential impact of each action on service availability, data accuracy, and adherence to established IBM Tivoli Netcool / OMNIbus v7. 4 operational guidelines, which implicitly support robust data handling and auditability. The correct approach represents best professional practice, because it prioritizes a systematic and documented investigation. By initiating a rollback of the recent configuration change and simultaneously engaging the vendor support team, the professional ensures that the system is returned to a known stable state while leveraging expert assistance to diagnose the root cause. This aligns with standard IT operational best practices and the implicit requirements for maintaining system integrity and audit trails, which are crucial for compliance and future troubleshooting. The decision to roll back is a controlled measure to mitigate immediate risk, and involving the vendor is a proactive step to resolve the underlying issue efficiently and correctly. An incorrect approach of immediately reverting to a previous backup without proper analysis fails to address the root cause of the current instability. This could lead to data loss or corruption if the backup is not perfectly aligned with the current operational state, potentially violating data integrity principles. Another incorrect approach, such as ignoring the alerts and continuing to monitor, risks further system degradation and potential service outages, which is a failure in proactive incident management and could have significant business impact. A third incorrect approach, focusing solely on applying a hotfix without understanding the impact of the original configuration change, could mask the problem or introduce new, unforeseen issues, demonstrating a lack of thoroughness and potentially violating change management best practices. Professionals should employ a structured decision-making framework when faced with such situations. This framework typically involves 1. Incident identification and assessment. Clearly define the problem and its immediate impact. 2. Containment and mitigation. Take steps to prevent further damage or disruption, e.g., rollback. 3. Diagnosis and root cause analysis. Investigate the underlying reason for the incident. 4. Resolution and recovery. Implement a permanent fix and restore full functionality. 5. Prevention and lessons learned. Document the incident and identify measures to prevent recurrence. In this case, the immediate rollback and vendor engagement represent steps 2 and 3, setting the stage for a complete resolution. Question 15. Analysis of a critical alert indicating a complete outage of a key monitoring service with an IBM Tivoli Netcool /OMNIbus v7. 4. Impacting the ability to detect and report on other system failures. The operations team is under immense pressure to restore service immediately. Considering the urgency, which of the following approaches best reflects a professional and compliant decision-making framework for addressing this situation? Option A. Declare the service unrecoverable and initiate a full system rebuild of the Netcool /OMNIbus environment, which is a time-consuming but guaranteed method of resolving all potential underlying issues. Option B. Implement a hastily developed script to restart the monitoring service components, bypassing standard change control and testing procedures to achieve a quick restoration, with documentation to follow at a later time. Option C. Immediately revert to the last known stable configuration of the affected monitoring service, document the action as an emergency fix, and initiate a full root cause analysis and permanent solution development post-restoration. Option D. Engage a senior engineer to manually reconfigure the affected service components based on their experience, without formal testing or documentation, to expedite the resolution. The correct answer is C. Immediately revert to the last known stable configuration of the affected monitoring service, document the action as an emergency fix, and initiate a full root cause analysis and permanent solution development post-restoration. Explanation. This scenario presents a common challenge in IT operations, balancing the immediate need for service restoration with the long-term implications of a hasty fix. Professional challenge lies in making a decision under pressure that adheres to established operational procedures and security best practices, while also considering the potential impact on system stability and data integrity. The urgency of restoring a critical service can tempt operators to bypass standard change control or testing protocols, which, while seemingly expedient, can introduce greater risks. The correct approach emphasizes a structured, risk-aware decision-making process. It prioritizes understanding the root cause of the outage and implementing a solution that is not only effective in the short term, but also sustainable and compliant with IBM Tivoli Netcool /OMNIbus v7. 4 best practices and any relevant internal IT governance policies. This involves thorough testing, proper documentation, and adherence to change management procedures, even under duress. This aligns with the principle of responsible system management, ensuring that interventions do not inadvertently create new vulnerabilities or operational complexities. An incorrect approach that bypasses standard testing and documentation procedures, even with the intention of rapid restoration, represents a significant regulatory and ethical failure. It violates the implicit trust placed in IT professionals to manage systems securely and reliably. Such an approach increases the likelihood of introducing unintended side effects, such as data corruption, security breaches, or further service disruptions, which could have severe operational and reputational consequences. It also undermines the integrity of audit trails and incident response processes, making it difficult to diagnose future issues or demonstrate compliance. Another incorrect approach might involve implementing a temporary workaround without a clear plan for a permanent fix. While this might restore service, it leaves the underlying problem unresolved, leading to recurring issues and increased technical debt. This demonstrates a lack of foresight and a failure to address the root cause, which is unprofessional and inefficient. The professional decision-making process in such situations should involve a rapid assessment of the impact of the outage, identification of potential solutions, and a quick evaluation of the risks associated with each solution. This should be followed by consultation with relevant stakeholders and adherence to established incident management and change control frameworks. The goal is to achieve the fastest possible resolution while minimizing risk and ensuring long-term system health and compliance. Question 16. The control framework reveals that a critical security patch for IBM Tivoli Netcool OMNIbus v7.4 has been released, addressing a known vulnerability. The IT operations team must decide on the deployment strategy for this patch. Which deployment strategy best balances the urgency of the security fix with the need to maintain service availability and minimize operational risk? Option A. Immediately deploy the patch across all production servers simultaneously to ensure all systems are protected as quickly as possible. Option B. Deploy the patch to a subset of the production environment first, monitor closely, and then proceed with a wider rollout if successful. Option C. Deploy the patch only in a dedicated test environment and consider the deployment complete once it functions there. Option D. Postpone the patch deployment until the next scheduled maintenance window to avoid any potential disruption. The correct answer is B. Deploy the patch to a subset of the production environment first, monitor closely, and then proceed with a wider rollout if successful. Explanation. The control framework reveals a situation where an IT operations team is tasked with implementing a critical update to the IBM Tivoli Netcool OMNIbus v7.4 environment. This update is essential for addressing a recently discovered security vulnerability that could expose sensitive network event data. The challenge lies in balancing the urgency of the security fix with the potential for disruption to ongoing network monitoring services. The team must decide on the most appropriate method for deploying the update, considering factors such as downtime tolerance, rollback capabilities, and the impact on service level agreements, SLAs. The correct approach involves a phased rollout strategy. This method prioritizes minimizing risk by deploying the update to a subset of the OMNIbus environment first, such as a non-production or a less critical production cluster. This allows for thorough testing in a live, albeit controlled, environment. If issues arise, the impact is contained, and a rollback can be executed with minimal disruption. This approach aligns with best practices for change management and risk mitigation, ensuring that the integrity and availability of the OMNIbus service are maintained while addressing the critical security need. It demonstrates a commitment to operational stability and adherence to established IT governance principles, which are implicitly expected within any regulated IT environment, even if specific regulations are not explicitly cited for this exam. An incorrect approach would be to immediately deploy the update across the entire production environment without prior testing in a staged manner. This disregards the potential for unforeseen compatibility issues or performance degradation, which could lead to a complete outage of the OMNIbus service. Such an action would likely violate implicit operational standards and could have significant business consequences, potentially breaching contractual obligations related to service availability. Another incorrect approach would be to delay the update indefinitely due to fear of disruption, thereby leaving the system vulnerable to the known security exploit. This failure to act on a critical security threat represents a dereliction of duty and a significant risk to data confidentiality and integrity. A third incorrect approach might be to rely solely on vendor documentation without performing any internal validation or testing, assuming the update will be flawless. This over-reliance on external information without due diligence is a common pitfall that can lead to unexpected failures. Question 17. Market research demonstrates that a critical OMNIbus probe is experiencing intermittent performance degradation, leading to delayed event processing and potential alert storms. The operations team is under pressure to restore normal service levels immediately. Which of the following approaches best balances the need for urgent resolution with sound IT operational principles? Option A. Temporarily disable the problematic probe and redirect its event sources to a secondary probe to maintain event flow, while deferring any investigation into the primary probe's issues until the next maintenance window. Option B. Initiate a rollback of the most recent probe configuration change, assuming it is the likely cause, and then proceed with a full root cause analysis if the issue persists. Option C. Immediately restart the affected probe and its associated object server to clear any temporary issues, and monitor for recurrence without further investigation. Option D. Engage the OMNIbus administrator and relevant application owners to collaboratively investigate the root cause of the performance degradation, document findings, and propose a targeted solution based on the analysis. The correct answer is C. Immediately restart the affected probe and its associated object server to clear any temporary issues and monitor for recurrence without further investigation. Explanation. This scenario presents a common challenge in IT operations, balancing the immediate need for system stability with the long-term implications of technical debt and potential security vulnerabilities. The professional challenge lies in making a decision that prioritizes operational integrity while adhering to established IT governance and risk management principles, which are implicitly governed by the principles of sound IT management and operational efficiency, expected within the context of IBM Tivoli Netcool /OMNIbus v7. 4 fundamentals. The decision requires careful consideration of the impact on service availability, data integrity, and the potential for future incidents. The correct approach represents best professional practice because it involves a systematic, risk-based evaluation. It prioritizes understanding the root cause of the performance degradation and its potential impact before implementing a solution. This aligns with the principles of proactive IT management, which emphasizes preventative measures and informed decision-making. By engaging relevant stakeholders and documenting the process, it ensures transparency, accountability, and a comprehensive understanding of the risks and benefits associated with any proposed action. This methodical approach minimizes the likelihood of unintended consequences and supports the long-term health and reliability of the OMNIbus environment. An incorrect approach that bypasses proper investigation and documentation would represent a significant regulatory and ethical failure. Specifically, it would violate principles of due diligence and responsible IT management. Implementing a fix without understanding the root cause could lead to unforeseen side effects, such as data corruption or further system instability, which could have severe operational and potentially financial repercussions. This lack of due diligence could also be seen as a failure to maintain the integrity and availability of the IT services, which is a fundamental expectation of IT professionals. Furthermore, bypassing established change management processes, even in an urgent situation, can lead to a breakdown in control and an increased risk of errors. Professionals should employ a decision-making framework that begins with a clear definition of the problem and its impact. This should be followed by a thorough investigation to identify the root cause. Once the cause is understood, potential solutions should be evaluated based on their effectiveness, feasibility, and associated risks. Stakeholder consultation is crucial at each stage to ensure alignment and buy-in. Finally, the chosen solution should be implemented following established change management procedures, with thorough testing and post-implementation monitoring. This structured approach ensures that decisions are informed, defensible, and aligned with best practices for IT service management. Question 18. Research into a proposed configuration change for the IBM Tivoli Netcool /OMNIbus v7. 4 event correlation engine indicates a potential for improved alert deduplication, but the exact impact on existing alert suppression rules and historical data aggregation is not fully understood. What is the most professionally responsible course of action? Option A. Conduct a thorough impact analysis, consult relevant system documentation and operational procedures, and seek formal approval from the relevant change advisory board or management before proceeding with any implementation. Option B. Postpone the decision to implement the change indefinitely, as there is no immediate critical system failure directly attributable to the current configuration. Option C. Rely solely on the recommendation of the junior administrator who identified the potential change, without further independent verification or consultation. Option D. Immediately implement the configuration change to leverage the potential benefits of improved alert deduplication, assuming the risks are minimal given the perceived urgency. The correct answer is A. Conduct a thorough impact analysis, consult relevant system documentation and operational procedures, and seek formal approval from the relevant change advisory board or management before proceeding with any implementation. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for system stability with the long-term implications of data integrity and operational efficiency within the IBM Tivoli Netcool /OMNIbus v7. 4. Environment. The decision maker must consider the potential impact of a hasty configuration change on ongoing monitoring, alert processing, and historical data, all while adhering to the principles of sound IT service management and the implicit guidelines for system administration within a regulated environment. The absence of a clear, documented precedent for this specific type of configuration adjustment necessitates a structured decision-making process. The correct approach represents best professional practice because it prioritizes a thorough understanding of the proposed change's impact before implementation. This involves consulting relevant documentation, assessing potential risks to system stability and data integrity, and obtaining appropriate authorization. This methodical approach aligns with the principles of change management, which are fundamental to maintaining reliable IT operations and are often implicitly or explicitly required by organizational policies and industry best practices, even if not tied to specific external regulations in this context. It ensures that changes are controlled, understood, and have minimal negative impact. An incorrect approach that involves immediately applying the configuration change without proper assessment fails to uphold professional responsibility. This bypasses essential risk mitigation steps, potentially leading to system outages, data corruption, or performance degradation. Such an action could be considered a breach of professional duty to maintain system integrity and could violate internal IT governance policies. Another incorrect approach, which is to defer the decision indefinitely due to a lack of immediate urgency, neglects the proactive nature of IT management. While not immediately catastrophic, delaying necessary configuration adjustments can lead to accumulating technical debt, reduced system efficiency, and a higher risk of future, more severe issues. This passive stance can also be seen as a failure to exercise due diligence in managing the IT environment. A third incorrect approach, which is to rely solely on the opinion of a single, less experienced team member without independent verification or broader consultation, introduces significant risk. This approach is susceptible to individual error or incomplete understanding and bypasses the collective knowledge and oversight that are crucial for critical system changes. It undermines the principle of shared responsibility and robust decision-making within an IT team. Professionals should employ a structured decision-making framework that includes clearly defining the problem or proposed change, gathering all relevant information, documentation, impact assessments, historical data, identifying and evaluating potential solutions and their risks, consulting with stakeholders and subject matter experts, making a reasoned decision based on the gathered information and risk assessment, documenting the decision and its rationale, and planning for implementation and post-implementation review. This systematic process ensures that decisions are informed, justifiable, and aligned with organizational objectives and best practices. Question 19. The evaluation methodology shows that during a critical service outage, the initial response team is tasked with understanding the full scope of the problem, considering the principles of effective incident management and the capabilities of IBM Tivoli Netcool /OMNIbus v7. 4. Which approach to impact assessment is most appropriate to ensure timely resolution while minimizing further disruption? Option A. Perform an exhaustive, multi-day impact assessment covering all potential dependencies and downstream effects before initiating any remediation actions. Option B. Immediately initiate remediation steps on the most likely cause without any formal impact assessment to expedite service restoration. Option C. Focus solely on the directly affected component and its immediate technical dependencies, disregarding broader business service implications. Option D. Conduct a phased impact assessment, starting with immediate critical business services and expanding the scope based on initial findings and the criticality of affected components. Correct answer is D. Conduct a phased impact assessment, starting with immediate critical business services and expanding the scope based on initial findings and the criticality of affected components. Explanation. This scenario presents a common challenge in IT operations, balancing the need for rapid incident resolution with the requirement for thorough impact assessment. The professional challenge lies in determining the appropriate level of detail and scope for an impact assessment when faced with a critical system failure. Overly simplistic assessments risk overlooking cascading failures or affecting unrelated critical services, while overly complex assessments can delay crucial remediation efforts. The correct approach, which involves a phased impact assessment starting with immediate critical services and expanding based on initial findings, represents best professional practice. This aligns with the principles of effective incident management, emphasizing swift containment and resolution, while ensuring that remediation actions are informed and proportionate. In the context of IBM Tivoli Netcool/OMNIbus v7. For fundamentals, this approach supports the efficient use of the tool's capabilities for event correlation and impact analysis, allowing operators to prioritize actions based on the most critical business functions affected. This methodology ensures that resources are focused on the most significant risks first, minimizing downtime and potential financial or reputational damage. An incorrect approach that focuses solely on the directly affected component without considering dependencies or downstream effects represents a significant regulatory and ethical failure. Such an approach could lead to the inadvertent disruption of other critical services, violating service-level agreements, SLAs, and potentially leading to regulatory penalties if those services are subject to specific compliance mandates. Ethically, it demonstrates a lack of due diligence in protecting the integrity and availability of all IT services. Another incorrect approach, which involves an exhaustive, multi-day impact assessment before any remediation is attempted, is also professionally unacceptable. This delays critical incident response, directly contravening the core objectives of incident management. The prolonged downtime would likely breach SLAs, incur significant business losses, and could result in reputational damage. From a regulatory perspective, such an action could be seen as a failure to meet obligations for service availability and business continuity. The professional decision-making process for similar situations should involve a structured incident management framework. This framework typically includes stages for detection, logging, categorization, prioritization, diagnosis, escalation, resolution, closure, and review. For impact assessment, the process should be iterative. Begin with a rapid assessment of immediate and obvious impacts, then escalate the depth and breadth of the assessment as needed, informed by the initial findings and the criticality of the affected services. Professionals should leverage the capabilities of tools like Netcool/OMNIbus to correlate events and understand service dependencies, enabling a more informed and efficient impact assessment. Prioritization should always be driven by business impact and service criticality. Question 20. The performance metrics show a significant increase in event processing latency across the IBM Tivoli Netcool/OMNIbus v7.4 environment, coinciding with a recent update to a critical network monitoring probe. Which of the following initial steps is the most appropriate for diagnosing the root cause of this performance degradation? Option A. Analyze the OMNIbus object server logs and performance counters for signs of resource contention or unusual processing patterns, while also reviewing the probe's recent event data and configuration. Option B. Immediately roll back the network monitoring probe update, as it is the most likely culprit. Option C. Focus solely on increasing the network bandwidth, assuming the increased event volume is overwhelming the existing infrastructure. Option D. Initiate a full system restart of all OMNIbus component to clear any potential transient issues. The correct answer is B. Immediately roll back the network monitoring probe update, as it is the most likely culprit. Explanation. This scenario presents a common challenge in IT operations, identifying the root cause of performance degradation when multiple factors could be contributing. The professional challenge lies in efficiently and accurately diagnosing the issue without causing further disruption or making incorrect assumptions that lead to wasted resources or prolonged downtime. The need for a systematic and evidence-based approach is paramount, especially within a regulated environment where system availability and data integrity are critical. The correct approach involves a structured impact assessment that begins with gathering comprehensive data from various sources, including the performance metrics themselves, system logs, and configuration details. This allows for a holistic view of the environment. By correlating events and identifying patterns, the team can isolate the most probable cause. This methodical process aligns with best professional practices by ensuring that decisions are data-driven and that potential solutions are targeted and effective. In the context of IBM Tivoli Netcool/OMNIbus v7.4 fundamentals, this translates to understanding how OMNIbus components interact and how external factors can influence their performance. The focus is on understanding the system's behavior under stress and identifying deviations from normal operation. An incorrect approach would be to immediately assume a single cause without thorough investigation. For example, solely focusing on network latency without considering potential issues within the OMNIbus object server itself, such as excessive event processing or resource contention, would be a failure. This could lead to misdirected troubleshooting efforts and a delay in resolving the actual problem. Another incorrect approach would be to make configuration changes reactively based on anecdotal evidence or assumptions, rather than on a clear understanding of the impact. This could introduce new problems or exacerbate existing ones, violating principles of change management and potentially leading to system instability. Ethically, such reactive measures could be seen as negligent if they are not based on a sound assessment of the situation, potentially impacting service-level agreements and customer trust. The professional decision-making process should involve 1. Acknowledging the reported performance degradation. 2. Initiating a structured data collection phase, leveraging OMNIbus's monitoring and logging capabilities. 3. Analyzing the collected data to identify anomalies and potential correlations. 4. Formulating hypotheses about the root cause. 5. Prioritizing hypotheses based on evidence and potential impact. 6. Testing the most probable hypotheses through controlled investigation or targeted changes. 7. Implementing solutions based on confirmed root causes and verifying their effectiveness. 8. Documenting the entire process for future reference and continuous improvement.